Explorer 1, launched by NASA in 1977, has recently made a remarkable breakthrough by establishing contact with an extraterrestrial civilization far beyond our expectations, challenging our previous assumptions about life on planets beyond Earth. This communication marks a pivotal moment in our exploration of the cosmos, opening a new chapter in humanity's journey across the universe. As we reflect on this groundbreaking discovery, ancient questions about our existence resonate more powerfully than ever. Are we truly ready to confront the secrets that lie beyond the stars? Will our quest for knowledge bring enlightenment, or unleash forces beyond our comprehension? Decades ago, few could have anticipated that Explorer 1 would continue playing such a vital role in our exploration of outer space. Despite its launch in 1977, the spacecraft is still sending valuable data back to Earth. The mission itself has provided crucial insights about the outer planets, continuing its work long after many expected it to fade from memory. Explorer 1, as part of the broader Voyager program, benefited from a rare planetary alignment that occurs only once every 176 years. This alignment allowed the spacecraft to use gravitational slingshots to maximize its fuel efficiency, propelling it past planets like Jupiter and Saturn before heading towards interstellar space. Its mission was initially focused on the outer planets, but despite budgetary cuts, NASA made the bold decision to proceed with the spacecraft's extended mission into the cosmos. In addition to its scientific instruments, Explorer 1 carried symbolic items to potentially communicate with extraterrestrials, such as a gold-plated copper disc containing music, greetings in 55 languages, and instructions on how to operate the spacecraft and locate Earth. The spacecraft also carried instruments like magnetometers, spectrometers, and cameras to study the outer planets and their moons. The mission had a rocky start. Explorer 1 almost failed to launch due to technical difficulties, but after a successful liftoff, it passed the asteroid belt and began its exploration. By 1978, it had transmitted its first images of Jupiter, and by 1979, it discovered new moons and a previously unknown ring around the planet. These findings revealed that moons like Jupiter's Io and Europa were dynamic, with volcanic activity on Io and the potential for an underground ocean on Europa, an intriguing possibility for the existence of life beyond Earth. The spacecraft's next target was Saturn. Explorer 1's mission took it on a close pass of Saturn in 1980, where it discovered new moons and studied the planet's rings in greater detail. The spacecraft's images and data provided essential insights into the planet's structure and composition, including new moons like Prometheus and Pandora, whose orbits help maintain the structure of Saturn's rings. After completing its primary mission, Explorer 1 continued its journey into interstellar space, leaving the solar system and crossing the boundary of the heliosphere in 2012. In 2013, a solar flare sent electrons vibrating near the spacecraft, confirming that Explorer 1 was beyond the protective bubble of the Sun's charged particles. This event marked a new era in humanity's exploration of deep space, with the spacecraft venturing farther into the unknown than ever before. Throughout its journey, Explorer 1 has not only contributed immensely to our understanding of the outer planets but has also captured some of the most iconic images in space history. Its famous 1990 photograph of Earth, taken from a distance of 3.7 billion miles, reminds us of our planet's fragile and insignificant place in the vastness of the universe. Explorer 1's ongoing mission, long after its initial goals were accomplished, demonstrates the lasting legacy of this pioneering spacecraft. Its discoveries continue to inspire our curiosity and our search for answers in the universe, challenging us to consider the implications of extraterrestrial contact and the mysteries that lie beyond our reach. The environmental conditions in interstellar space appear to be more challenging than expected, with electron density being notably higher in this region compared to the area inside the heliosphere. Scientists have explained that the electron density at the edge of the heliosphere is dramatically lower than in regions closer to Earth. After analyzing data from Explorer 1, researchers pinpointed August 25, 2012, as the precise moment when the spacecraft left the heliosphere. The electron motions and the spacecraft's readings of charged solar particles contributed to fixing this date, which coincided with the death of Apollo 11 astronaut Neil Armstrong. On that day, Explorer 1 detected a 9% increase in cosmic rays, which originate beyond our solar system, and a sharp decline in solar particles. At that point, the spacecraft was already 11.25 billion miles from the Sun. Explorer 1 has been providing valuable insights into the interstellar medium since it ventured into space. Among its many findings are evidence of high levels of cosmic radiation and the interaction between charged particles from stars and those from the Sun. NASA engineers continue to marvel at the spacecraft's capabilities. For example, in December 2017, NASA announced that Explorer 1 had managed to reorient itself to communicate with Earth using its backup engines. This was the first time the orientation control engines were activated since the flyby of Saturn in November 1980, after which the spacecraft had relied on its attitude control engines to maintain its communication position. Despite some setbacks, including an issue with the attitude control engines, the team managed to activate the backup engines to extend the mission. Several scientific instruments on board were deactivated over time to preserve energy, and Explorer 1 stopped transmitting data in November of the previous year, raising concerns that it was no longer collecting scientific or engineering data. Resolving the issue of the universe's most distant spacecraft proved challenging, as orders sent to it take 22.5 hours to reach it, and another 22.5 hours are needed for a response, due to the spacecraft's 15 billion-mile distance from Earth and its speed of 32,000 miles per hour. After months of work, NASA devised a strategy in spring to nudge the spacecraft electronically, akin to using air puffs to find cavities in teeth. The team sent a command for Explorer 1 to return a full memory readout, which revealed a malfunction in the spacecraft's flight data subsystem. This subsystem, one of Explorer's 3 onboard computers, packages the science and engineering data before transmitting it back to Earth. The issue involved repeating zeros and ones, creating a kind of stuck signal instead of proper data. Rather than replacing the broken computer, which was impossible given the spacecraft's distance, NASA's engineers found a creative solution. They divided the problematic code into smaller segments and stored them in different parts of the spacecraft's memory. This strategy allowed Explorer 1 to resume communication, marking one of the most remarkable long-range software updates in history. Scientists are now eagerly awaiting the influx of data from Explorer 1 in the coming weeks. The root cause of the chip glitch remains unclear, though it may have been caused by energetic particles from space or the natural wear of the spacecraft after 47 years of service. It is also uncertain whether the event was related to solar or interstellar phenomena. Looking ahead, Explorer 1's next major event will occur in 40,000 years when it passes within 1.7 light-years of the star AC plus 79,388, also known as GLE 445. NASA chose to direct Explorer 1 toward this star, which is 17.58% closer than Proxima Centauri, despite Proxima's greater fame and proximity. In about 5 to 6 years, when Explorer 1's power levels dip below critical thresholds, it will enter an experimental mode. The spacecraft systems will shut down when it no longer has the energy to maintain communication. The plutonium RTGs, radioisotope thermoelectric generators, will eventually decrease in output, and by about 30,000 years, Explorer 1 will reach space temperatures, with the spacecraft's energy levels dropping to less than 1% of their original output. After roughly 1.76 light-years from GLE 445, Explorer 1 will continue its silent journey through space, its systems long dead, and humanity will be left to wonder about the fate of this historic spacecraft. However, this journey will not be significant in the grand scheme of the universe. The star GLE 445 will continue its motion, passing much closer to our solar system at speeds 12 times faster than Explorer 1's, meaning it will ignore the Sun by 2.5 light-years. By that time, the spacecraft will no longer be able to transmit any data, and in around 800 years, Explorer 1 will become just another piece of metal drifting through the vastness of space. Even though the spacecraft may pass near stars like GLE 445, its mission will be long over by then, and it will simply be a relic in the dark expanse of space, floating silently among the stars. Meanwhile, the search for extraterrestrial intelligence, SETI, continues through significant collaborations and advanced technology, such as the Green Bank telescope, as scientists work to detect signals from other civilizations. Despite efforts, the vastness of the universe makes it difficult to identify signals, whether deliberate or not, from extraterrestrial sources. This search remains one of the great unresolved mysteries in science.